You're back for day 2 of the quadratic formula. There it is. Remember, this thing depends totally upon you being in standard form before you begin your process. And in our whole list of ways that we can solve quadratic equations, we're at item number 4, which means we've progressed quite a ways. If things are going according to plan, you've already watched a video about how you can kind of work the mechanics of this, find the A's, the B's, and the C's, and what this plus minus means. And the subject for today is then getting this to give us an answer to an equation. So here's an example. And we're going to go more in depth on this in a little bit. But if I had to solve this equation, I have many different techniques available to me now, as you know from that list, but we're going to choose the quadratic formula. And the first thing I would ask myself is, am I in standard form? Aha, I am in standard form because ax squared plus bx plus c, ax squared plus bx plus c. I'll go back to that example in a second, but what I've just done is I've verified that my equation is in standard form. That's the first step to solving with the quadratic formula. Then you'll see after that we're going to write down our values for a, b, and c, being careful to not get messed up by negatives. And then we're going to plug those values into the quadratic formula. And then carefully, and I do mean carefully, we're going to simplify that down into a number. As you go along this path, beware of negatives and subtraction, because negatives and subtraction are your enemy in algebra, and you might find that out here. So we decided this was in standard form. Step 2 on our list says write down the values for a, b, and c. You see the values, but write them down separately so that you can be a little bit more careful about the plugging in. And now when I do this plugging in, you'll notice that you have to be super meticulous. For example, the value for b is negative 11. So where I see a b, I want to write a negative 11, but there's also this negative outside that. So what I'm really writing is a negative 11. Negative 11. This is what I mean about being careful, and being careful especially with negatives. Plus or minus. Now I have the square root, and on the inside I have to do the b squared minus 4ac. Well, there's my b, so b squared minus 4 times a times c. I'm just very carefully choosing my values to plug in all over 2a. Once I've plugged all this in, being very careful for the negatives, I have this convenient dot dot dot. I can eventually get to my answer, but I have to kind of compute or grind through this arithmetic very carefully, and that's what we're going to show next. Instead of the convenient dot 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 leading to the answer, because that's a fairy tale, we're going to go over the actual steps. So what I have is my initial plug-in for my values of a, b, and c. And now I'm just going to go little by little. A negative 11 is a positive 11. A negative 11, when I square it, plug it into your calculator if you need to, that's 121. These three numbers multiply to 120. Notice that that subtraction sign stayed, the plus or minus stayed, and 2 times 2 is 4. All right, so I've done one little step to turn it into this. This is definitely looking a little bit better. Now I'm going to go one little tiny baby step further. This minus this is 1. It's not always going to work out to be that convenient. But notice that nothing else changed. I just turned this into a 1. I don't want to do more steps than I need to for each, I don't want to do more thinking than I need to for each step. I just want to make one tiny decision per step. The square root of 1, by the way, is 1. That's kind of awkward. If this were a 16, say square root of 16, then I would have a 4 over here. But it just happens that the square root of 1 is a 1. So that's the only thing I changed from here to here, is that square root. At this point, I'm back to the familiar, I have two paths. I have the 11 plus 1 divided by 4 and the 11 minus 1 divided by 4. I suggest strongly that you draw those arrows and you take two paths. Now from here, the numerator is 12 divided by 4. The numerator is 10 divided by 4. And I have the two answers I got before when I conveniently did the dot, dot, dot. But now we're showing you the calculations that have to happen to make that work. It's pretty tedious and there's some good chances to make mistakes, so be ultra careful. We're going to go through one more example. Our next example is right here, and we're going to solve, but I just want to remind you we're going to be following these steps up here, and the real star of the show is this beautiful quadratic formula. These steps are how we solve that thing. So if I look at those steps, the very first thing I have to think about is my equation in standard form? And it definitely isn't, because to solve this, the left side needs to be in standard form and the right side needs to be equal 0. So I notice this minus 3x needs to take a trip over to the left-hand side, so I need to get it into standard form. That's pretty easy. To move a minus 3x, I add 3x, and there's no like term to combine it with over here, so it just works its way in. And now look at this, ax squared plus bx plus c. Aha, I'm in standard form. The next step, according to our checklist, is write down the values for a, b, and c. There's my a, there's my b, there's my c, so I'm going to write those down. Even if I think I can look up and see them, it's better to just write them down because it's being very, very organized and meticulous with this formula. The next step was to plug those values in. Don't do anything more than just plugging the values in. So now in this case, when I do negative b, b is positive, so negative b, plus or minus b squared minus 4ac all over 2a. Now I've chosen this example because if you look at this part right here, there's some danger lurking because there's subtraction and negatives. So it's a very popular place to make a mistake, but you don't want to be popular, do you? So let's look at what we did. The negative 3 stays, there's nothing to do with that. 3 squared is 9, so that's an easy decision. But now I very, very highly recommend that you do this. This piece right there is subtraction. I would just rewrite that every time and then ignore it and then just say 4 times 4 times negative 10. So treat that subtraction as subtraction and then ignore it when you compute the value of these three numbers multiplied by each other. 4 times 4 is 16. 16 times negative 10 is negative 160. Now when I do that, this negative and this subtraction are going to interact here very shortly. And by the way, the denominator turns into an 8. Minus a minus is a plus. Your middle school teacher told you that. So notice that from here to here, the only thing that changed was the minus. I know that this is a danger area, so I'm going to be very careful and I'm going to write down more steps on my paper than I really think I need. Now I can turn this into the square root of 169. Nothing else changed. And the square root of 169, according to my brain or my calculator, is 13. So by turning that into a 13, that's the only thing that changed from here to here, is that turned into a 13. Now I see two different paths. Negative 3 plus the 13 divided by 8, negative 3 minus the 13 divided by 8. I treat each path separately and I get my two answers. These are the two x values that make that original equation work, but notice how much work and how much attention to detail you're going to need along the way. That's the quadratic formula. Anytime you're working on that quadratic formula, please make sure you're following those 4 steps.